Every year, more than 3 million tons of herbal tea are consumed worldwide, and the United States alone imports over 100 million pounds of dried herbs for tea production. But behind every cup of chamomile, peppermint, or hibiscus tea lies an intricate journey from seed to shelf. How do farmers cultivate delicate herbs without pesticides? How do solar-powered facilities transform fresh leaves into shelf-stable products using nothing but sunlight? And what makes clean energy processing the future of sustainable agriculture? All will be revealed in this video. Welcome to AgriCraft. Herbal tea, also called tisane, has been consumed for thousands of years across every inhabited continent. Unlike true tea, which comes from the Camellia sinensis plant, herbal tea is made from flowers, leaves, roots, bark, seeds, and fruits of various plants. Ancient Egyptians drank chamomile for its calming properties. Traditional Chinese medicine has used chrysanthemum and ginger for millennia. Indigenous peoples of the Americas brewed mint and echinacea long before European contact. Today, herbal tea represents a global industry worth over $8 billion annually. The United States is the second largest consumer market after China, with Americans drinking over 80 billion cups of tea per year, and about 20% of that total consists of herbal varieties. The demand for organic, sustainably grown herbal tea has exploded over the past decade. Consumers want products grown without synthetic chemicals and processed using renewable energy. This shift has driven innovation in cultivation methods and processing technology, particularly the adoption of solar drying systems in clean energy facilities. Traditional herb drying relied on sun exposure in open fields or rudimentary structures. While simple, this method exposed herbs to dust, insects, bird droppings, and unpredictable weather. Moisture levels were inconsistent, leading to spoilage and quality issues. Modern solar drying facilities solve these problems by combining passive solar design with controlled environments. These facilities use transparent roofing, thermal mass, and strategic ventilation to create optimal drying conditions while maintaining hygiene standards and food safety protocols. The result is a superior product that meets international quality standards while using zero fossil fuels for the drying process itself. For American farmers and entrepreneurs interested in value-added agriculture, solar-dried herbal tea production offers a profitable entry point into the specialty food market. Let's begin at the farming stage, where the journey of herbal tea production starts with seed selection and cultivation planning. The most popular herbs for tea production in the United States include peppermint, spearmint, chamomile, lemon balm, hibiscus, lavender, echinacea, and nettle. Each herb has specific growing requirements, but most prefer well-drained soil, moderate fertility, and full sun exposure. Farmers select varieties based on climate, market demand, and processing capabilities. For example, peppermint thrives in cooler regions like Oregon, Washington, and Michigan, while hibiscus requires warmer climates like California, Florida, and Hawaii. Chamomile grows well across the Midwest and Northeast. Farmers source seeds or starter plants from specialized nurseries that provide certified organic or non-GMO genetics. Quality seed stock is essential because it determines the concentration of essential oils, flavonoids, and other compounds that give herbal teas their flavor and therapeutic properties. Site preparation begins months before planting. Farmers test soil pH and nutrient levels, adjusting with organic amendments like compost, aged manure, or green manure crops. Most herbs prefer slightly acidic to neutral soil, with pH levels between 6 and 7. Good drainage is critical because many herbs are susceptible to root rot in waterlogged conditions. Farmers often create raised beds or mounded rows to improve drainage. Some operations use drip irrigation systems to deliver water directly to plant roots, conserving water and reducing disease pressure. Cover crops like clover or vetch are planted during the off-season to fix nitrogen, suppress weeds, and improve soil structure. This practice reduces the need for external inputs and builds long-term soil health. Planting methods vary by herb type. Annual herbs like chamomile are direct seeded in early spring using mechanical seeders that space seeds precisely for optimal plant density. Perennial herbs like peppermint, lemon balm, and echinacea are often established from transplants or root divisions. Farmers space plants according to variety, typically 12 to 24 inches apart in rows separated by 30 to 48 inches. This spacing allows adequate air circulation, which reduces fungal diseases and provides room for cultivation equipment to pass between rows for weed control. Young plants require consistent moisture during establishment, so farmers monitor soil conditions closely and irrigate as needed. Within 4 to 6 weeks, most herbs develop robust root systems and begin rapid vegetative growth. Weed management is one of the biggest challenges in organic herb farming. Without synthetic herbicides, farmers rely on mechanical cultivation, mulching, and hand weeding. Tractor-mounted cultivators with specialized sweeps or tines pass between rows, uprooting small weeds while leaving crop plants undisturbed. Straw or wood chip mulch is sometimes applied around plants to suppress weeds and conserve moisture. Hand weeding is labor-intensive but necessary for areas close to plant stems where mechanical tools cannot reach. Some farms use flame weeders, which use propane torches to quickly kill young weeds without disturbing the soil. The key is consistent attention because weeds compete for nutrients, water, and light, reducing herb yields and quality. Pest and disease management in organic systems relies on prevention and biological controls. Herbs are generally less susceptible to pests than food crops, but aphids, spider mites, and caterpillars can cause problems. Farmers encourage beneficial insects like ladybugs, lacewings, and parasitic wasps by planting flowering borders and maintaining habitat diversity. Neem oil, insecticidal soaps, and botanical extracts are used as needed to control outbreaks. Disease prevention focuses on promoting good air circulation, avoiding overhead irrigation, and removing infected plant material promptly. Crop rotation is practiced to break pest and disease cycles. For example, chamomile might be rotated with grains or legumes to prevent soil-borne pathogens from building up. As the herbs mature, farmers monitor daily for signs of peak harvest readiness. Timing is everything in herbal tea production because the concentration of essential oils and active compounds fluctuates throughout the plant's life cycle. For leaf herbs like peppermint and lemon balm, harvest occurs just before flowering when essential oil content is highest. For flower herbs like chamomile and lavender, harvest happens when flowers are fully open but before they begin to fade. For root herbs like echinacea, harvest takes place in fall after the plant has stored energy reserves underground. Most herb farms harvest multiple times per season, a practice called cut and come again harvesting. After the first cut, plants are allowed to regrow, and a second or even third harvest follows. This maximizes yield per acre and extends the harvest season from late spring through early fall. Harvesting methods depend on the scale of operation and the type of herb. Small-scale farms often harvest by hand, using sharp knives or pruning shears to cut stems cleanly without damaging plants. Hand harvesting allows for selective picking, ensuring only the best quality plant material is collected. Workers move through fields in the early morning after dew has evaporated but before the midday sun reduces essential oil content. Fresh herbs are immediately placed in breathable containers like wooden crates or mesh bags to prevent crushing and maintain airflow. Larger operations use mechanical harvesters adapted from hay or forage equipment. These machines cut herbs at a uniform height and deliver them onto conveyor belts that feed into collection bins. Mechanical harvesting is faster and reduces labor costs, but it requires careful adjustment to avoid damaging plants and ensure clean cuts. Transportation from field to processing plant happens quickly to preserve freshness and prevent wilting. Herbs lose moisture rapidly after cutting, and exposure to heat or sunlight accelerates degradation of essential oils. Farms located near processing facilities transport herbs within hours of harvest using covered trucks or trailers. The herbs are kept in shallow layers to prevent heat buildup and maintain air circulation. Upon arrival at the processing plant, herbs are immediately unloaded and moved to pre-processing areas where initial sorting and quality inspection begin. The processing plant is where the transformation from fresh herbs to finished tea really begins. Modern solar drying facilities are architectural marvels designed to harness passive solar energy while maintaining strict hygiene standards and food safety protocols. The buildings typically feature south-facing glass or polycarbonate panels that allow maximum sunlight penetration while blocking UV radiation that can degrade plant compounds. Interior walls and floors are constructed from materials with high thermal mass, such as concrete or brick, which absorb heat during the day and release it slowly at night, maintaining stable temperatures. Ventilation systems include strategically placed vents, louvers, and fans that control airflow and humidity without consuming excessive energy. Some facilities incorporate solar panels to power fans, lighting, and automated systems, making them entirely off-grid. Upon arrival, fresh herbs undergo initial quality inspection. Trained workers examine each batch for signs of disease, pest damage, contamination, or foreign material. Any substandard plant material is removed at this stage. The herbs are then weighed and logged into a traceability system that tracks each batch from field to final package. This documentation is essential for organic certification and food safety audits. Next comes the cleaning stage. Herbs are gently washed using automated washing systems that spray clean water over the plant material as it moves along conveyor belts. The water pressure is carefully controlled to remove dirt, dust, and small insects without bruising delicate leaves or flowers. After washing, excess water is removed using centrifugal spinners similar to those used in commercial salad processing. These machines spin herbs at controlled speeds to extract water while minimizing damage. Now the herbs move to the drying area, the heart of the solar drying facility. Herbs are spread in thin layers on food-grade mesh trays stacked on mobile racks. The trays allow air to circulate freely around the plant material, ensuring even drying. Each rack holds dozens of trays and can be moved easily throughout the facility to optimize exposure to heat and airflow. The drying room is a climate-controlled space where temperature, humidity, and ventilation are carefully managed. During sunny days, temperatures inside the facility can reach 90 to 120 degrees Fahrenheit, ideal for rapid yet gentle drying. Solar collectors and thermal chimneys enhance natural convection, drawing moist air out and pulling fresh, dry air in. Humidity sensors trigger ventilation fans when moisture levels rise too high. The goal is to reduce moisture content from about 80% in fresh herbs to below 10% in dried herbs. This level prevents mold growth and ensures long shelf life. Drying times vary by herb type and environmental conditions. Delicate flowers like chamomile may dry in as little as 12 to 24 hours, while thicker leaves like peppermint require 36 to 48 hours. Throughout the drying process, workers rotate trays, check moisture levels, and monitor for any signs of overdrying or scorching. Overdried herbs become brittle and lose essential oils, while under-dried herbs risk mold contamination during storage. Achieving the perfect balance requires experience and attention to detail. Some advanced facilities use moisture meters that provide instant readings, taking the guesswork out of the process. Once herbs reach the target moisture content, they are immediately removed from the drying racks and moved to the next stage. Post-drying processing involves additional sorting and grading to ensure only the highest quality material reaches consumers. Dried herbs pass through vibrating screens or mechanical sifters that separate leaves from stems and remove any remaining debris. Stems are typically composted or used as animal bedding because they contain fewer essential oils and are less desirable for tea. The sorted leaves and flowers are then graded based on size, color, and aroma. Premium grades consist of whole leaves or intact flowers with vibrant color and strong fragrance. Lower grades may include broken pieces or slightly faded material, which are often used in blended teas or teabag products. Quality control teams conduct sensory evaluations, brewing samples to assess flavor, aroma, and appearance. They also test for contaminants like heavy metals, pesticide residues, and microbial loads. Only batches that meet stringent standards proceed to packaging. Sterilization is an optional but increasingly common step, especially for herbs destined for export or sensitive markets. Some facilities use steam sterilization, which briefly exposes herbs to high-temperature steam to kill any remaining bacteria, mold spores, or insect eggs. This process is carefully controlled to avoid cooking the herbs or degrading their quality. Other facilities use ethylene oxide or irradiation, though these methods are controversial and not permitted in organic production. Steam sterilization remains the preferred method for organic herbal tea producers because it is effective, leaves no residues, and maintains the integrity of the product. Packaging is the final stage before herbs leave the facility. Modern herbal tea operations use automated packaging systems that fill, seal, and label products at high speeds while maintaining hygiene standards. Dried herbs are fed into hoppers that dispense precise quantities into various package formats, including bulk bags, retail pouches, tea bags, and tins. For loose-leaf tea, herbs are typically packaged in resealable pouches made from laminated materials that provide moisture and oxygen barriers. These packages protect the herbs from environmental degradation and extend shelf life to 18 to 24 months. Some premium brands use biodegradable or compostable packaging materials to appeal to environmentally conscious consumers. Teabag production is a specialized process that requires additional machinery. Dried herbs are ground or cut to a consistent particle size using industrial mills or choppers. The ground material is fed into teabag machines that automatically dispense measured amounts into filter paper pouches, seal them, and attach strings and tags. Modern teabag machines can produce several hundred bags per minute, making them highly efficient for large-scale production. The teabags are then packed into boxes or tins, which are labeled with product information, brewing instructions, and expiration dates. All packaging materials must comply with food safety regulations and be suitable for direct contact with food products. Labeling is critical for regulatory compliance and consumer information. Labels include the product name, ingredients, net weight, country of origin, organic certification logos, and contact information for the manufacturer. Nutritional information is sometimes included, although herbal teas typically contain negligible calories, fats, and proteins. Brewing instructions guide consumers on water temperature, steeping time, and serving suggestions. Traceability codes allow the product to be tracked back to the specific batch and field where the herbs were grown. This level of transparency builds consumer trust and meets the requirements of certifiers and regulators. Storage of finished products takes place in climate-controlled warehouses where temperature and humidity are carefully managed. Herbal teas are sensitive to heat, light, and moisture, so they are stored in cool, dry, and dark conditions to preserve quality. Warehouses are equipped with inventory management systems that track stock levels, expiration dates, and order fulfillment. When orders arrive, products are picked, packed, and shipped via refrigerated or ambient freight depending on destination and season. Distribution channels include direct sales to consumers via e-commerce, wholesale to retailers and specialty stores, and export to international markets. The United States exports significant quantities of herbal tea, particularly peppermint and chamomile, to Europe, Asia, and the Middle East. These markets value the quality and safety standards associated with American agriculture and food processing technology. Beyond the primary product, herbal tea production generates valuable byproducts that contribute to sustainability and profitability. Stems, lower-grade leaves, and plant material rejected during sorting are composted and returned to the fields as organic fertilizer. This closed-loop system reduces waste and improves soil health. Some farms collect stems for distillation, extracting essential oils that are sold to the cosmetics, aromatherapy, and pharmaceutical industries. Peppermint oil, lavender oil, and chamomile oil command premium prices and provide additional revenue streams. Spent plant material from oil distillation is composted or used as animal feed. Even the water used in washing systems is filtered and recycled, minimizing water consumption and environmental impact. Culinary applications for herbal tea extend far beyond simple beverages. Dried herbs are used in cooking, baking, and cocktail making. Chamomile adds floral notes to cakes and pastries. Peppermint enhances chocolate desserts and lamb dishes. Hibiscus provides tartness and vibrant color to sauces, syrups, and beverages. Bartenders use herbal infusions to create innovative cocktails, and chefs incorporate them into molecular gastronomy. Herbal tea blends are also popular for home brewing, with consumers mixing different herbs to create custom flavors and therapeutic combinations. The versatility of dried herbs makes them a staple in both home kitchens and professional culinary operations. From a nutritional and health perspective, Herbal teas offer numerous benefits without calories or caffeine. Chamomile contains apigenin, a compound that promotes relaxation and improves sleep quality. Peppermint aids digestion and relieves symptoms of irritable bowel syndrome. Hibiscus is rich in antioxidants and has been shown to lower blood pressure. Echinacea supports immune function, particularly during cold and flu season. Lemon balm reduces anxiety and enhances mood. These health benefits are supported by scientific research, making herbal tea a popular choice for health-conscious consumers. Unlike pharmaceuticals, herbal teas are generally safe, affordable, and accessible, though people with specific health conditions, or those taking medications, should consult healthcare providers before consuming therapeutic herbs regularly. The environmental impact of solar-dried herbal tea production is significantly lower than conventional processing methods. Traditional herb drying often relies on fossil fuel-powered ovens or dehydrators, which consume large amounts of energy and emit greenhouse gases. Solar drying eliminates these emissions, making the process carbon neutral or even carbon negative when combined with organic farming practices that sequester carbon in soil. Water use is also minimized through efficient irrigation systems and recycling of wash water. Organic cultivation avoids synthetic pesticides and fertilizers, protecting pollinators, soil organisms, and water quality. The result is a product that supports biodiversity, reduces pollution, and contributes to climate change mitigation. Economic benefits extend beyond environmental sustainability. Solar drying facilities have lower operating costs because they do not require fuel purchases for drying. While initial construction costs may be higher due to specialized design and materials, the long-term savings are substantial. Farmers who process their own herbs capture more value per pound compared to selling fresh herbs to intermediaries. Direct-to-consumer sales via farmers markets, online stores, and farm stands generate even higher margins. The growing demand for organic and locally produced herbal tea creates opportunities for small and mid-sized farms to enter profitable niche markets. Government programs supporting renewable energy and sustainable agriculture provide grants, loans, and technical assistance to help farmers transition to clean energy processing systems. In the United States, several regions have emerged as hubs for herbal tea production. The Pacific Northwest, particularly Oregon and Washington, dominates peppermint and spearmint cultivation due to ideal climate conditions. The Midwest produces significant quantities of chamomile, echinacea, and lemon balm. California leads in lavender and hibiscus production. These regions benefit from established infrastructure, experienced growers, and proximity to processing facilities and distribution networks. University extension programs and agricultural research centers support the industry through variety trials, pest management research, and education programs. Industry associations provide networking opportunities, market intelligence, and advocacy for favorable policies. Looking forward, the herbal tea industry is poised for continued growth driven by consumer trends toward health, wellness, and sustainability. Innovations in agriculture technology, including precision irrigation, drone monitoring, and automated harvesting, are making herb farming more efficient and profitable. Advances in solar drying technology, such as hybrid systems that combine solar and biomass energy, are improving reliability and expanding the geographic range where these facilities can operate. Blockchain and other traceability technologies are enhancing transparency and building consumer trust. As more farmers adopt clean energy processing and organic cultivation methods, the environmental and social benefits of herbal tea production will continue to expand. From seed selection to solar drying, from quality inspection to final packaging, the journey of herbal tea production showcases the incredible potential of sustainable agriculture and clean energy processing. This is not just a story about making tea. It is a story about harnessing renewable energy, honoring plant traditions, and building food systems that nourish people and protect the planet. As automated systems and industrial machines improve efficiency while maintaining hygiene standards and food safety, and as more American farmers embrace organic cultivation and renewable energy, the future of herbal tea looks bright. This industry demonstrates that profitability and sustainability can go hand in hand, creating opportunities for rural communities and delivering high-quality products to consumers who care about where their food comes from and how it is made. Thank you for watching AgriCraft. If you enjoyed this exploration of solar-dried herbal tea production, please give this video a thumbs up, subscribe to the channel, and share your thoughts in the comments below. What sustainable farming practices or clean energy technologies would you like us to cover next? We look forward to hearing from you, and we will see you in the next video.